Isolation and switching. Bless him, a colleague of mine looked at this earlier when it was still in the draft for public comment, and he said to me, oh, chapter 53, it is turgid. And I went, okay. I went and got a dictionary. I looked up what turgid meant. It's bloody hard to read, is what it means. It's a lot of words. It's hard to go through. Chapter 53 has changed quite dramatically to have a lot of information in. But a lot of the information is just information. It's a bit like 46 earlier where we said there's a lot of words, but it starts just putting more bits around it. It has put a little bit more onus on the designer to not just know what they are doing, but to prove it. It's not just knowing that you've got selectivity, not discrimination, selectivity, but proving that you've got it. And one of the phrases that has been implemented is this term called desk study. And what it realistically means is that you think that device will work in series with that device. Remember that picture of the overcurrent protected devices with a fault at the bottom? You hope overcurrent protected device 2 will blow, not 1, but it's proving it. The term desk study has been put in to say, can you prove it? Do you know that that circuit breaker, that RCD, will work in series? And it might mean getting some manufacturer's literature. It might mean getting some software to prove that those two devices work in series. Because you could have a 400 amp breaker in series with another 400 amp breaker. There's the bay windows. I tell you what, this villa's getting nice now. I might have a bedroom soon. It's putting two devices in series. And if you tune one all the way to the top and one all the way to the bottom, then you might have selectivity. But it's not what you think. It's what you can prove. So the term desk study is there to prove that you've got selectivity. Oh, this is a good one. If we all went out now to our nearest wholesaler and I said, get me a B-type RCBO, pretty sure you'd all come back with the same thing. Did you know there are different types of RCDs as well as types of circuit breakers? Guy nodding there? A B-type, C-type, D-type circuit breaker is different from a B-type or A-type or AC or F-type RCD. This is an important one for anybody who is doing electric vehicles. Do we have anybody installing them, EVs? A couple of people, one or two? It's going to be a growing market, inevitably. I haven't checked this myself, so I'm not 100% sure, but a colleague told me that all new houses now have to be provided with an electric vehicle charging point. Did anybody see that in the paper the other day? Yeah? So we need to provide facility for EV charging. There are four main types of RCDs. There's other ones, but the four main ones are AC, which is your bog standard, buy from the wholesaler. That'll be on the shelf. A's, B's, and F's. And they all have slightly different characteristics. Old RCDs used to be a coil with a bit of cable and a push button on. These ones are all very, very clever electronic equipment. And because they're clever electronic equipment, they're not just a coil with a push button on. They all react slightly differently to DC systems, or anything with microcomputers on the end of it, or anything that has a DC feedback. And in some cases, you can have some installations that will blind, stop your RCD from working. If you fit a standard AC RCD to a system that has a lot of power electronics on it, it might not work. So in part 5, it talks about the different types of RCDs. If you are fitting a system that needs a different type of RCD, make sure you get the right type. So you might have a B-curve circuit breaker and a B-type RCD, or a B-curve circuit breaker and an A-type RCD. Guess what the difference is between AC and Bs? About that, about 100 quid. Don't get the wrong ones. If you're pricing up on ACs, you're going to end up out of pocket. I don't think anybody in here is a charity. Take this information away with you, aware of the different types of RCDs. Some systems need an A or a B type, and it's not the B, C, and D curve. Is that good? We okay? Earlier on, we looked at SPDs and where they are needed, where they're not needed, doing a risk assessment and the likes. Once you've decided you need an SPD, 534 tells you what to do with it, where to fit it, how to fit it, at length of cabling and all that sort of stuff. And it's same pretty much as before. Once you've picked out the fact that you need an SPD, 53 will tell you what is needed. I said it's simpler, but it's still quite difficult to read, to understand, to get to grips with the whole area of SPDs. So what we've done is we've teamed up with a company called Dane, or Den, however you pronounce it. And they're writing us a guide to SPDs with ECA Technical. And at the moment, it's, I think it's about 50 odd pages, all about the risk assessment, what is needed, how to do the risk assessment. And then once you've done the risk, where to fit them, and how to design them properly. By the time it's finished, it's probably going to be knocking on for 70 pages with pictures and things in. And what we'll do is we'll put it on our website. Guess how much it's going to cost? Free. Out of interest, do you guys think there is enough information out there about SPDs? Yes? No. Who's going to go on our website and download it for free? Hey! Keep an eye out for it. We'll let you know when it comes out. I've seen a couple of drafts of it already. It's really good. It's really useful, and it's very, very practitioner-led. It is not overly scientific. It is about how to fit them, where to fit them, what to do. Generally, it's not actually that difficult. Type 1 at origin, 2 at subboards, and 3 further about. And even if you just use all the same manufacturer, you will effectively get selectivity. That's pretty much it. We've put it down in a lot of information, and it will be coming out shortly to you guys for free. Draft for public comment, when that was out. There was a proposal for all TN systems to have an additional earth electrode. Did you see that? It's not in. Didn't make it. It is not in. There is information about TT systems and foundation earthing, but it's only for TT systems. The proposal to have an additional earth electrode on TN earthing systems has not made it. We don't have to do that. Do you know why? Partly because you guys voted against it. This is a second area where your thoughts and opinions genuinely made a difference. I was chatting with a friend of mine. Works for a little company called NIC EIC. Have you heard of them? And he was working on the helpline one day. Do you get many TT systems around here? No? Yeah? He was working on the helpline one day, and somebody phoned up and went, "You all right, mate?" Yeah, he had a bad voice. "You all right, mate? Doing a TT system. Can you give us some help?" Yeah. What's your question? "Well, I'm testing my earth rod." Right. "Well, I don't know what's a good reading or not." All right, what have you got? 0.01 ohms. 0.01 ohms? Yeah. Not being funny, mate. Are you doing it right? Yeah, I'm not an idiot. No, of course you're not. 0.01 ohms. Are you sure? Have you got the leads right? Yeah, no, I told you, I'm not an idiot. What do I do with it now? What do you mean, what do you do with it? Well, it's still sat on my desk. Testing the end-to-end. Tell you what, mate, take it back to the wholesalers, give it back to them, take up plumbing. Water goes downhill, that's all you need to know. TT systems, bless him. This reg for TN systems to have a supplementary earth electrode hasn't made it yet. It might come back again in the future. Please keep your eye out for the next draft for public comment, because there will be another draft for public comment coming out at some point, because the regs, because of the reasons we said at the start, will change, new technologies, new requirements. It will alter and move. There will be another proposal at some point, no doubt, to put earth electrodes in. And in theory, if you've got a TN system where you've lost the neutral on a PME system, then it might help, but you've got to get the rod down to about 10 ohms so as it actually is functional. Personally, I'm not sure it's a practical idea. I can't see it being suitable. So when it does come out, I'm going to vote against it. And if you feel strongly about it, Get your vote in. We'll ask you, so we'll take your comments to the committees as well, but feel free to comment yourself. It is good to get involved.